So stacking. So stacking is one of the technique to build the ensembles models. So stacking models, in this lecture we will discuss the stacking models. So this is the one of the technique to build an ensemble models. To build an ensemble model. Okay, this is one of technique. So already we have discussed the boosting technique. Already we have discussed the bagging technique, then we have discussed the boosting technique, and in third we will discuss the stacking technique. So first we will discuss bagging technique. We have discussed the bagging technique. Then we have discussed the boosting technique. Now we will discuss the stacking technique to build an ensemble model. Stacking technique. So let's see step by step. So first, what do we have to do? We have a given data sets, that is the training data sets, and in generally the training data sets, the form of training data sets look like this: xi, yi, where I is from 1 to n, This is simple, our training data sets, and using these training data sets, we have chosen the classifier models, that is C1, C2, such kind of different classifier models. That is totally, these are the independent to each other. So these are the independent to each other. The first criteria of these models are the independent. Our classifier models, if we taken the taken classifier models is much different, then our ensemble model is give the much more accuracy. So the main criteria of taken this classifier model is that the models are the independent. First criteria is models are independent. Since it is independent, we can doing this job parallelly. Okay, we can doing this job parallelly in H-core, or in, if you have a petabyte of data, a large amount of data, then we can easily doing this job in parallel boxes. So it is parallelizable. It is parallelizable. Okay, we can easily doing these jobs. So here, suppose an example, from this example, say here we have taken these classifier models, and m such classifier we have taken here. We have taken such m classifier models. M classifier models, and after this stage, after this building this stage, means what? Here C1 is means what? C1 means simple. Here if you just see this thing, C1 means simple here H1x, C2 means what? Simple H2x. Base learners, one kind of base learners here. In the stacking technique, these classifier models are one kind of base learners. Suppose HMX. And using these models, we have built a new data. That's already, we will see these things. Just first see the constructions of these stacking models. Okay. Now, what is the C1? The C1 is here. C1, C2, what is look like? The C1, C2 are look like this kind of sets. So the C1, suppose let's take C1, C2, C3. So all are the different models, not same kind of. In bagging technique, what we have taken? In bagging for build the random forest, we have taken the same kind of base learners. That is taken for random forest, we have taken the base learners as decision tree. For bagging technique, for boosting technique, what we have taken? We have taken the same kind of base learners. And the advantage from the bagging to the base boosting is that the model is depend on the previous models. With the help of the previous models, we can build the next models. That is the advantage. Now, and in stacking models, it is the advantage is that this is a totally different to each other, totally independent, and totally different kind of classify this model C1, C2, the totally different kind. Suppose let's take our C1 is linear SVM. Suppose let's take linear SVM. then C2 will be any other that is not same kind of any other. Suppose let's take it is the RVF SVM. Then C3 will be gradient boost decision tree with 200 decision with 200 here k is equals to 200, with base learners is equals to decision tree is equals to 200. And suppose let's take we have chosen C4 is equals to naive Bayes model. Suppose let's take C5 is equals to k nearest neighbor model with k is equals to, suppose let's take 5. Suppose let's take k C6 is equals to knn with here k is equals to, suppose let's take 4. So all the things are totally different. All the linear SVM is totally different from the RVF SVM, and GVDT is totally different from these two differences. So here the edge models, edge based models are totally different from each others, and we have trained these edge models by using these training data sets independently. This is the first concept of the stacking. Now in second stage, what we are doing in the second stage, after training the edge classifier, edge based models, edge based learners model, after training these edge based learner models, we have to build a meta classifier model. So we have to build a meta classifier model. That is, we have to build this meta classifier. And how these things are building. So suppose let's take we have a query point. Suppose let's take we have a query point xq. We have a query point xq. Now after training this, we have the edge m models we have, and similarly we applying the xq for edge classifier, for edge models c1, c2, c3 up to cm. We have applied these edge models, and after applying this cq, we will get this output. Suppose let's take its output is yq1. Its output, let's take its yq2. Its output is yq3. yqm. We will get this output, and using this output again we will build a model using this output, and this model is called the meta classifier. Again we build a model, and these models are called the meta classifier. Meta classifier, and this is our final models. So these models that taken all the combinations of the previous models, these models are actually, it may be different total. It may be linear regressions, it may be decision tree, it may be logistic regressions, anything. So it is totally different from the previous ones. So any models we can take to take the final output from the previous outputs. Okay, this is the simple diagrammatically view of the stacking model. So first we have given a data sets, that training data sets, and using these training data sets we have trained edge modeled. Edge means it's different model, is totally different models, and independently we have trained edge different model independently. And after this, after and in edge models, we taken the output for a query point, and using this output, we have built another meta classification model, and these meta classifications model are also totally different from the previous ones. Okay, this is the simple concept. This is the simple concept of the stacking models. And at the end of the day, the output of the meta model, a meta classifier, is actually will be the final predictions of our algorithms. Now let's see the algorithm step by step, what actually we have to do in these models. So first, in the first step, what do we have to do? We have to take on this is the flow chart of our stacking models, and this is the algorithms, all our algorithms. This is the simple algo of the stacking models. So in the first step, what do we have to do? In first steps, we have to given the data sets D training data sets. So we have given a training data sets. D is look like this: xi, yi, I is equals to, suppose let's take 1 to m if we have m number of data points. Suppose let's take, and like that our value will be like that. So in output, what will be output? Our output will be an ensemble classifier. Okay, that's our interest to build this. But first, in step 1, what do you have to do? In step 1, learn first level classifier. First, we have to initialize first level classifier. First, we have to learn the first level classifier. Okay, and the next stage, we have to decide how much classifier we have to take. Suppose let's take, we have to take here t number of classifiers. And now using these data sets, first step, we have to doing this job. Okay, first step we have to do. In the second step, what do we have to do? In the second step, that thing we have to do in the second stage. In the second stage, we have to choose the number of classification models totally different from each others. And suppose let's take here we have chosen t number of such classifications, and using these data sets we have to train this t number of classifications. Suppose let's take the ht. Suppose let's take the t number of classifications classifiers are h1, h2, h3 up to ht. We have to build this using these data sets. Okay, now after end of this things, we have to construct a new data sets. So how, now the question is how we will construct these data sets. So by using these constructed data sets, we using the output of the previous models. We taken the output of the previous models, means how the things actually this data output construct the in step 2, that is in step 2, the constructions of the data new data set, construct the new data set d dash from the d. Okay, this is the main thing. How will, suppose let's take, we have here how much data we have here, how much data is equals to 1 to m. So here our data number of data set is equals to I is equals to 1 to m. So to construct these data sets, we have to follow this thing. So our data sets usually look like this. So here we have the data independent variable is what? xi. From xi independent variable is xi, and corresponding original output is yi. So using this value, so we have to build the d dash data sets. So d dash data sets will be look like xi dash yi. Now question is, what is actually xi dash? Xi dash actually look like this. This is the set of the output value of the previous classifier. So this is output value. So suppose here we have given a query point xq. Here giving a query point xq. So this xq is applicable from here, this applicable on here, applicable on here. So using this xq on these models, if we apply those, so the output of this xq will be what? Predictions, means predictions of the c1 is what? Predictions of the h1 xq, its prediction will be h2 xq, and its prediction will be hm xq. Okay, this is the simple predictions. By using these predictions, we have built another independent variables. So here the xi dash will be h1 xi, comma h2 xi, dot up to ht. How much classifier we have taken? ht xi. This is simple our xi test. Okay, these things we have to choose. So this is the second step we have to do. Okay, now at the stage 3, we have to do learn a second level classifier. Means we have to build, by using these data sets, we have to build this meta classifier. This is called the second level classifier. This is called the first level classifier. These levels are called the first level classifier. First level classifier, these things called the second level classifier. Okay, now we have to, now our target is using these data sets d dash. We have to build the second level classifier. So the learn a new classifier that we have to build, that h dash. Now the second, this classifier is called the h dash. each test based on the new constructed data sets. So now we, at the end of the day, we have to return this value h of x. H of x will be simple h test of this h test the h test. These models, these h models will be linear regressions, logistic regressions, decision tree, as we use, as depend on our data sets, depend on our situations, in which environment we have built our models, what is actually a requirement, when which if you take in the medical domain, then our accuracy our main target is the accuracy, then here then time is not matter. But if we doing this job in an internet company or some low latency situations, so there accuracy does not matter. The matter is the time, how much time we have taken to give the output. So that is totally depend on our situations and what is kind of data sets. If your data set dimension of the data set is so large or not, your data length of the data set is what, dimension is what is your situations. So everything, every parameters are responsible to choose your right models. So that's the another thing. But the main thing is that stacking model, in stacking model, the main thing is that this is the simple image of the stacking models. First, we have given the training data sets. Using these training data sets, we have taken the different kind of models, and we are using this training data using this training data, we are trained the each different type of models, and these models are called the first level models. And using the predictions of the each models, we have to build another models, and these models are called the meta classifier models, meta classifier, and these models are called the second level classifier model. Okay, this is the simple thing that we have to do in stage 3. After stage 3, we will return the final value of our models. That the job we have to do in stacking. That now let's see actually the some code examples. I am taken this from the Google image, and just search it on stacking models, and that you can easily find those images. I am, for easy of discussions, for time, for easy understanding, I am taking these things from the Google. You can easily find it on if you just search it. Okay, this is the thing. Just to see now let's see the code examples, how this actually works. Actually, I'm taking the Python code, and suppose let's see. So easily we can install these things, and this actually ML extent. You can easily just search it on Google, ML extent. You can easily find this kind of code. Okay, suppose let's take. So this is the some packages we have to install first. So and these are the things we have to need. First, we have installed these packages as our requirement. Now, after that, we will take on here 3 classifiers. Classifier 1, 2, 3. So, first classifier I am taken here the k nearest neighbor classifier with neighbor point 1. Second classifier we have taken here the random forest classifier with random state 1. And the third is we have taken here the Gaussian naive Bayes classifier. Okay, these 3 classifiers we have taken here. So our first h of 1x, it's simple classifier 1, that I am taken the 1 nearest neighbor. h2x will be the classifications 2, and this is the random forest. This is the simple random forest classifier, and h3 of x is simple the Gaussian naive Bayes, means class 3. It's the simple Gaussian naive Bayes classifier. And using this classifier, we have to build the meta classifier. So meta classifier, to build the meta classifier, I am taking here the linear regressions. The meta classifier we have taken here, means here h test of x. I have taken here the logistic regressions that I have taken. Okay, so now by simple the stacking classifier at the final of the day, the stacking classifier will be the stacking final output will be the stacking classifier, and the classifiers are taken here, class CLF1, CLF2, CLF3, and the meta classifier have taken here the LR. Okay, I think from the code perspectives you will understand that how these things are actually the stacking classifier, how these things are actually work. We have to don't worry about this, all the things are internally work, just we have to define the which classifier we have to choose and corresponding parameter of the edge classifier we have to take. Just we have to doing these jobs, and everything's are internally doing in Python. It is the so easy task. Okay, so first job is we have to choose our proper classifier, and after that we have to choose our what will be our meta classifier. That is jobs we have to do to build a stacking models. After using this, we have to take on the cross validations. We have to take the cross validations. So here we have taken the three-fold cross validations. So for three-fold cross validations, I am just using these jobs. First, I am using these jobs for first I am taking the KNN, then the random forest, then an naive Bayes, then stacking classifier. We have to define these models. And after these model selections, we have cross validation score. We have taken the scores. We have find its scores. What will be actually its score of the edge of the stacking classifier. Okay, and this is the simple code. And the main thing, the main job is we have to do these things. These are the main part. But the rest of the things are okay. Okay, I think you have understand the main algorithm, main structures of the stacking model, how these things are actually work. Actually, these stacking algorithms are mainly useful in the Kaggle competitions. In Kaggle competitions, there have a various kind of concept and various kind of public that enterprise to build and models. Okay, suppose let's take we are taken and the data sets. Suppose let's take we have taken the data sets dn, and we have to give and we have to give in situations that in the situations our requirement is we have to build and models that accuracy we need is greater than 95%. The accuracy we will need is greater than 95%. Okay, that is our task. We have to build it. For a given conditions, we have given some data sets and we need some models that give the accuracy 95% with some conditions. Okay, so first job we have to do? First we have to choose our classifier models h1x, h2x. Suppose let's take up to htx. We have to choose this classifier. So the question, the main motto will be the more different mesh models, the output results will be that better. So the first job will be more different the base models. Actually, these are the base models. So the more different the base models, so the output result will be that better. The better output will be. This is the main job we have to first do. Now the second thing is to build a models to doing these jobs. So actually, if you see all the base models are totally different to each others. So to build one models and suppose to build and random forest, to build and logistic regressions, to build and something. So this is some time taking matter and they have some resources if we have a large amount of data sets. So to build these things, we have to group our classes. Suppose let's take we have built our team to build a stacking models. Actually, in a single person, it is totally impossible, because actually they have some huge amount of resources, huge amount of time taken. If we parallelly doing these jobs, I think then it will be better and it will get the more accuracy. So first we have to make a team to build these stacking models. So the teamwork will be So first task, suppose the first task, first team, for team 1, this is team 2, and suppose let's take this is the team's team. Then first the team 1, it decided that we have built, suppose we have built 15 such models. We have built 15 such models. The team 2 decided, no, we have built 20 such models. Then team 3 decided at the suppose we have built 5 such models. So at the end of the day, if we take the output from the each teams, so how much models actually we have built here? So 20, 20, 40 models we have built as base models. Now using these 40 models from team 1, team 2, team 3, we have built a meta model. Finally we have built a meta model. And the meta model, these meta models, the age dashed, these meta models are give the more accurate output than the previous ones. Okay, and these things are actually workable in a real world. In many actually we have see the many internet company, many large company like Google, Microsoft, Amazon, such kind of companies are using these techniques, stacking technique, to build a proper accurate model. Okay, now the questions is this is the so complex, and age based model are complex and totally different from the each others, so this may be time taking matter. The questions is this is the time taking matter. Yes, to build this stacking model, it is time taking and resource taking matter, but the time taking is the one time effort. So this is the third thing is that, so it is the time and resources taking matter. Takes a lot, but it is one time effort. To build such models, it is the single one time effort we have to choose. So this is the simple thing. Actually the internal, in stacking models, internal doing these jobs, so everything's are okay. So but the main thing that we have to take in the base models are totally different from each others, and we are independently we have to train the age based models that is not different from each other. And after that training, that we have collected all the output predictions, and using this output we have to train another models that will give the final output. That's the main job that we have to do to build a stacking model. Okay, I think from this lecture the concept of the stacking model, how these things are actually internally work, I think it is okay.